Hello, this is the presentation for a night tour. Um, we have three people in the group, which is Jordan Chen, Colin Chen, and George Lee. My name is George, so I'm George Lee. So let's begin. Introduction. What's night tour problem? Night problem is a really classical problem that's discovered in 9th century in India, and it is an example of problem known as Hamilton path. The problem states that on an untimed chessboard, using a single knight and starting at a chosen position, move the knight such that it visits every square on the board, but visits no square more than once. So why it's challenging to solve? Firstly, the knights can choose any choices for next step. Secondly, knights are blinking between blocks, not as clarified as other chess, which moves through lines. Thirdly, the size of the board is n. The bigger n is, the harder the question is. Fourthly, the difficulty of the question increases exponentially and reach the limit of processability. There's some other solutions, which is BFS, breadth first search. The advantage of BFS is one of the solutions can be found rapidly. It can list all paths without extra backtracks, and the disadvantage is for listing all solutions. It is time wasting and not effective. The second one is DFS, which is depth first search. The advantage of DFS is for listing all solutions, and it's efficient. And the disadvantage of DFS is when DFS is enabled, more time is needed to backtrack for another path. Okay, here is the algorithm we choose, which is backtracking algorithm. Backtracking algorithm is slow, but it reaches dead end and it's reevaluate many decisions. The Wonsdorf rules can be used as improve or optimize the naive algorithm. When the knight has chosen next step, it will always proceed to square from which it has the fewest onwards moves. This heuristics reduce the probability that the knight won't be able to visit some square. Okay, the next step is Jordan, who will present the next one.
Hello, my name is Jordan and I will be doing the next part of the slides. For the demonstration, we decided to use Java as the software to explain the problem. We didn't write the code, but we found the code from the website listed in the slide, and we tried to understand everything that the code is writing so we can explain it. Moving on to the next slide, this is the class of Knight's Tour, where the first thing we will do is to initialize the integer for not visited, which is an indicator where to show that the square is not yet visited. The next part of the code is to initialize the width of the chessboard, which is named x size, and to initialize the height of the chessboard, which is named y size. We then will have to initialize solutions count. This will count how many possible solutions have been counted through the whole program. The next initialization is to initialize an integer array called solution board, where it will store the matrix of each possible solutions counted. We will then have to create a main method for the whole program to run, where inside the main method there will be a for loop, and inside the for loop we will have to create a Knight's Tour object where there will be two parameters, one being the x-axis and the y-axis, in other words the width and the height. The next line will be the object called kt.solve, which is a method that will be implemented later on. And finally, when at the end of the program, it will print out the number of solutions counted in the program. We move on to the next slide, where we will see the constructor for this class, again with two input parameters, one being the width, one being the height, and inside this constructor we will set the solutions count to 0, as there will be no solutions count currently. Then we will have to initialize the solution board with the new integer of height and width, and after that we will have to implement two for loops, a nested for loop to be exact, one with the limited size of limited height and limited width set by the constructor itself, and inside it will set the solution board to not visited, as in the whole thing has not been visited, any square has not been visited. And we carry on to the next slide, which will show the method solve. Inside this method solve, we will use another nested for loop, again with limited of the height and limited of the size, which will be set by the constructor. Inside this nested for loop, it will implement a method called takeTurn, and again it will be implemented later on. This will pass in three input parameters, one being the x coordinate, the y coordinate, and 0, which will be the number of turns it has taken. We will then set the x and y coordinate, which is the exact square in the board, to not visited. This is to reset the square each time you solved it. We move on to the next slide, where we will have the method called getFields, which will have again two input parameters, x and y. Here we will implement a list, an array list to be exact, called L. The purpose of this method is to move the knight to its new coordinates. We will be using the if-else statements. So for example, if the x plus 2 is less than the width and y minus 1 is more than equals to 0, the knight will move right and upward. This will be repeated throughout the whole process with each if statements, and at the end of the method it will return the new coordinate. Now I will pass on to my groupmate Colin to the next part of the slides. Thank you.
As we know, knights can move to different directions. The code on this slide shows how the knight decides the direction of its next step. The code in this slide has two parts. One modulus shows how to print out the solution of Knight's Tour steps. Another modulus will display how many solutions of Knight's Tour on the board we provided. And this part of code shows how to represent coordinates. In this slide, we can see an example of our program. Firstly, we enter the size of the board by the value of x is 3 and y-axis is 4. Then after a while, the program calculates all solutions, display each result and numbers of all solutions in console. However, our program also has some limitation or constraints. The first one is the speed of the algorithm is more reliant on hardware. which means different PCs have different results. Because it has more repeated calculation than other solutions such as BFS and DFS. Another limitation is the backtracking algorithm can calculate almost all the solutions but takes more time compared to the other algorithm. The naive backtracking algorithm has limited space to optimize because it has no function to skip repeated steps compared to BFS and DFS.